All right, this lesson is going to be all about how ions form or ion formation. I have a little cartoon up here for you. It's two atoms talking to each other. One says, I lost an electron. The other one says, are you positive? It's a little science joke. You might get it and you might not. But by the end of these notes, hopefully it makes sense to you. We'll come back to it and see. So, we know that we have a whole bunch of different atoms that exist, as many as there are on the periodic table, and each one has a different number of protons, neutrons, and electrons. However, some of those atoms are more stable than others. And what makes an atom stable is having a full outer shell of electrons. If you remember earlier in the year, we talked a lot about valence electrons. And we know that in the first shell of an atom, you can fit 2 electrons. The second one, you can fit 8. And the third one, you can also fit 8. And if that outer shell is full, then that is a very stable and happy atom. Now, there's only one group of atoms on the periodic table that naturally is stable. Do you know which group that is? Okay, maybe if you look at these pictures, it will be helpful. So I want you to look at these, and you have them in your notes as well, and see which ones of these do you think are the most stable. Remember that making something, or an atom being stable, means that it has a full outer shell of electrons. So look at the ones in your notes, which match the ones on the screen, and see if you can't circle the one that is the most stable. Or maybe there's more than one that are stable. All right, so if you look at this first one, remember the second ring is full if it has 8 electrons. This one only has 6, so it is not full, therefore it's not stable. If you look at the second one, this first ring can hold 2 electrons, and it has 2 electrons. So this, you can circle that one. That is a very stable atom. That is helium. And then this next one, again, second ring can hold 8, and if you count the electrons in there, 1, 2, 3, 4, 5, 6, 7, 8, it has a full shell. And this element is neon with 10 protons and 10 neutrons and 10 electrons. And if you notice, so both of these are circled because they're both stable. If you look at your periodic table, which will be really helpful to have out as you move through these notes, helium and neon are both in that group 8, which we call noble gases, the group all the way on the right side of the periodic table. And those elements, everything in that group, that vertical group, will always be stable. They're like the celebrities of the atom world. They all naturally have a full outer shell, which is what every other atom in the periodic table wants. So they are kind of the cool kids, all right? You can take a second and write that down as well. So, like I said, the only ones that naturally have that full outer shell are those group 8 elements. There's like 7 or so of them. But the rest of them, the rest of the 118 elements, they don't have a natural full outer shell, so they have to work for it. And what they do is they can actually gain or lose electrons to get that stable configuration of a full outer shell. So let's look at an example. Let's look at sodium. Find sodium on your periodic table. It is over towards the left. It's in group 2, okay, which is the second vertical column. And according to the information on the periodic table about sodium, what is sodium's atomic number? You'll see that sodium has an sodium's in group 1. It has an atomic number of 11, which means it has 11 protons. So I'm just going to write 11 pluses because protons are positively charged, if you remember from last trimester. Okay, and it also has, because they're neutral, if it has 11 protons, it has 11 electrons. So let's add those to the picture. In the first ring, we can fit 2 electrons. So here they come, 1, 2. Second ring, you can fit up to 8. So they're going to start filling in. 1, 2, 3, 4, 5, 6, 7, 8. Now that's 10 total electrons, but we need to have 11, right? So we need to add one more ring, and that last one goes into that final ring. Now, if you look at the configuration of sodium, is sodium a stable atom? Meaning, does it have a full outer shell? Well, no, because that last shell actually can hold up to 8. It only has 1 electron there. And sodium, so sodium's sitting here thinking, I'm not stable and I wish I was stable. What can I do to be stable? Well, we have a couple of options. Either sodium can try to gain 7 electrons to fill that shell, or it can try to get rid of this one and just use this as a full shell. So what do you think is easier for sodium to do? To gain 7 or to lose 1 electron? Hopefully you said to lose 1. There it goes. If you get rid of that electron, that ring has nothing in it. And now look, we're left with a full shell from the next ring in. So we have to look here though, because we changed sodium a little bit. So we have how many protons still? Did we change that? Nope. We still have 11 protons. Okay. Electrons though, we lost 1 electron. We used to have 11, we lost 1, so now we only have 10 electrons. So we have 11 positive charges and 10 negative charges, meaning we have 1 extra positive charge, right? That's not going to be canceled out, which means that sodium is no longer neutral. It's stable, but it's not neutral. It now has a charge on it, and because we have an extra proton, it has a +1 charge. So we would write this now as sodium +1. Okay? Here's another example for you. Fluorine. Find fluorine on your periodic table. Fluorine has an atomic number of 9, so it's going to have 9 protons. 9 protons, it's also going to have 9 electrons, 2 in the first ring, and the leftover 7 in the next ring. Okay? Now if we look at fluorine, fluorine also, does it have a full outer shell? Well, there's 7 electrons in this shell. The shell can hold 8, so no, it's not quite full. Now fluorine has a couple options as well. Either it can try to gain 1 electron to fill that shell, or it can try to lose all 7 of these so that it uses this as its full outer shell. What do you think is going to be easier, to gain 1 electron or to lose 7? Well, fluorine agrees that gaining 1 is going to be easier, so it's going to steal an electron from another atom. Okay? Now, fluorine has 8 electrons in its outer shell, so it's happy, it's stable. Okay? But again, let's count this up. How many protons do we have? We never changed the number of protons, so that's still going to be 9. Okay? But electrons, this time we gained an electron. We used to have 9, but we gained 1, so we have 10 now. Okay, so we have 9 protons, 10 electrons. This time we have an extra electron, right? An extra negative charge, which means we'll have a charge of -1 on that atom. Okay? Now's a good time to pause the video if you're confused and ask Ms. Bankston to clarify these pictures for you. Otherwise, continue on. Okay? So if you look at these pictures, and you also have these pictures in your notes, if you look here, this is lithium. Okay, do you think lithium is going to get this full outer shell, it either has to lose 1 or gain 7? It's probably going to lose 1. Next one over here, oxygen is either going to gain 2 to make that 8, or it's got to lose 6. Most likely it's going to lose 6. I'm sorry, gain 2. All right, for this next atom, okay, we're out into the 3rd ring here. This one also can hold up to 8. And if you count, we have 1, 2, 3, 4, 5. So to get that to be a full outer ring, either we have to gain 3 to get that up to 8, or we have to lose 5. It's probably going to be easier to gain 3. So this phosphorus atom will gain 3 electrons to become stable. And our last example is aluminum. And aluminum's also using that 3rd ring, which can hold up to 8. Aluminum has 3 electrons in that outer ring. So it either needs to gain 5 to fill that ring, or it needs to lose these 3 so that that ring goes away. It's probably going to be easier to lose 3 than gain 5. Okay, so you can see there is reason, a rhyme and reason to why and how many the electrons these atoms gain or lose. They always want to take the easiest path. Okay, now depending on if they gain electrons or lose electrons, remember that sodium ended up being positive and fluorine ended up being negative. Well, we have names for these. If you have an atom that ends up with a positive charge on it, we call that a cation. Okay, I remember that cations are positive because that T in the middle is like a plus sign. If you have an atom that ends up with a negative charge, kind of like fluorine did, then that's what we call an anion. And I remember that anions are negative because there's an N in there. Okay, so cations are positive, anions are negative. So sodium formed a cation and fluorine formed an anion. All an ion is just an atom with a charge, either positive or negative. And then we can be more specific and say, is it a cation or an anion? Now, short of drawing a picture of every atom whose charge you want to figure out, you can actually use your periodic table to help you figure that out. Because if you remember back when we talked about valence electrons, everything in the same group is going to have the same number of valence electrons. Therefore, they're going to do the same thing to become stable. So everything in group 1 has 1 valence electron. So in group 1, either you want to gain 7 electrons or lose 1 electron. They're all going to act the same way. Now, because they all have the same number of valence electrons, they'll all form the same charge when they form an ion. And if you need to gain 7 or lose 1, you're probably going to lose 1. And when you lose 1 electron, all of these elements are going to end up having a +1 charge when they form an ion. Okay. For the same reasons, everything in group 2 is going to want to lose 2 electrons, and therefore everything in group 2 would end up with a +2 charge. Okay. As always, we skip these guys because they don't like to follow rules. So we're going to come over here to group 3. Everything in group 3 would like to lose 3 electrons, and therefore will have a +3 charge. Now notice it seems kind of backwards. If you lose 3 electrons, you get a +3 charge. But if you're losing negativeness, you're losing electrons, you're going to end up positive. Okay. Group 4, it's either going to gain 4 or lose 4. But because we can't really tell if it's going to gain or lose, we usually skip that one as well. So we'll look at group 5. Group 5, they're going to want to gain 3 electrons, and therefore they'll end up with a -3 charge. Group 6, -2 charge. Group 7, all of those will have a -1 charge. And group 8, remember these are our celebrities. They're already stable. These guys all already have a full outer shell, and therefore they will not form an ion. They don't need to do any work to become stable. All of these guys are the ones that need to do work to become stable. Okay, so make sure that you write this in your notes and on your periodic table as a reminder, so that you don't need to draw pictures of every element to decide how is it going to form an ion. Okay, now very typical sheet that you'll see. This is an ion sheet, and this is a process that you need to get used to doing. We're going to do it together, and then you guys will be completing your simple ion sheet for practice. So we have here an ion name, which is fluoride. Now, if you have an anion, you change the end of it to "ide." So we're looking for fluorine on our periodic table. And for fluorine, you notice that it has 9 protons. Okay. Now, fluorine had 9 protons. And we noticed that before, when we did this example, remember, fluorine wanted to gain an electron. So it will want to gain 1, right, to get that full outer shell. And if it gains 1 electron, how many electrons is it going to have? Well, it's going to have 10 electrons. 9 protons, 10 electrons. So if we have 1 extra electron, and electrons are negatively charged, our ion symbol is going to have a -1 charge on it. So we write F, which is our symbol for fluorine, and you put that -1 on there because you have a -1 charge with that extra electron. Now, we want to know, what noble gas is this fluoride ion trying to be like? Remember, they're trying to be stable, just like all of that group 8 elements. So which element has 10 electrons? If you look at your periodic table, that would be neon. Neon has an atomic number of 10. Okay. Now, another example will leave out different information. So this time we know we have 16 protons and 18 electrons. Okay, that means we know, because normally it would start out at 16 and 16, that we must have gained 2 electrons there, because there's 2 more than the number of protons. So we gained 2 electrons. We know, since we have 16 protons, that this is sulfide. Sulfide has an atomic number of 16. Okay, and so the symbol for sulfide is S, But we gained 2 electrons, so that means it must have a -2 charge. So S -2 would be the ion symbol.